Yeah, so the first question was about on the discussion questions and the format of the report. I really am looking for ACS style in introducing equations, having the equation, and then describing what all the variables are. So just to get practice with introducing equations and then formatting the equation where you have the equation in the center and you have the number over on the far right. I talked to you a little bit on the board about that, but let me go ahead and let me just pull up a Word document. Let's see what this is. I don't know, let me just grab one just to get Word open. Okay, so I'm just going to open a new blank document. Come on. Hello. Okay, blank document. Okay, so you're going along. Here is the most amazing thing in equation 1. Okay. And then we want equation 1. So what you want to do is this up here, if you see that little L, that's a left tab. Okay? And if I were to put that, let's say I put that right here, or you have to drag it over here. No, I think you have to push it. Okay, well now I have a center tab. So how did I get the center tab? Well, you click this little tab thing and you click through all of them. It's like a little toggle. It goes through all these different things. So we're back to the left tab. If you click it once, you get the center tab. So I want to put this center tab right in the center of the page. And then I want to put this right tab, the one that looks like a backwards L, way over here. So I click close to that thing and then I drag it over to where it's right on the right margin. And now this line is formatted for an equation. So I can hit tab and notice it goes to the center. If I hit tab again, it goes all the way over to the right. And then whatever I type over here is stuck to the right margin. And whatever I type here in the middle is centered in the middle of the page. And so that's where you want your equation. So you can tab over twice. You can do 1. So there's your equation 1. And then go back to the middle, and then you can enter your equation here. Okay. Now I'm going to tell you what I'm doing live. You can't see it because I'm tapping on the keyboard. I mean, you can come up here and you can say insert. This is the slow way to do it. Insert equation. They have some sample equations here. That's fine. We'll just pick this simple one here. Boom. And it puts it in there. And then we change whatever it is. Say we want to do y equals mx plus b. Okay, so there's our linear equation. Great. Now, I could come down here and I could say where, m is the slope, etc., right? So then we have another equation coming up, equation 2. Now, I could go do those tabs and things again, but that's slow. It's tedious. Or I could come up here and I could select this whole line and copy it. How can that be? Insufficient memory to copy an equation?
You can, but should you?
Yeah. Anyway, so I don't know what that error was about. Okay, so then I just pasted it down, changed it to 2, and double click on the equation and make it a new equation. That's the fastest way to do it. Okay. More typing, more typing. Let's say I want to refer to the product of mx in typing. So when the slope is multiplied by x, something happens. Right. Now I want to say I want to put mx in there, but I want it to be formatted like an equation just because it'll look nice, right? So you can go through here and you can I put parentheses in here, and inside the text you can insert an equation. So insert equation, okay, mx. Is that fine? Yeah, so you can see that. In fact, if you want this x to look like that x, you can come up here and highlight it. Now watch when you hit the Alt key. Look up here at the top. When I hit the Alt key, I hit Alt, and all of a sudden I get letters everywhere. See all those letters? Okay, insert is in. So if I hit in, it picks the insert. And if I hit E, it picks the equation. And if I hit I, it inserts the equation. And it just turns that into an equation. Okay, 3 letters. In, let's see, I do it so fast. It was N-E-I, yeah. So if I'm typing along and I say the linear equation, this is helpful for your thesis because you're going to be using lots of equations perhaps. Chemical formulas work too. The linear equation, and I want to type in y equals mx plus b right here. I do. Watch carefully. Alt, N, E, I. Never have to take my hands from the keyboard. Y equals mx plus b. Right arrow, and then I'm back to text. Is so easy. Okay. So you can Alt N-E-I, Alt N-E-I, Alt N-E-I. That is, you don't hold Alt down while you do that. You just hit Alt and let go, N-E-I, and it gets you into the equation mode. So that's a nice little fast thing. Okay. So we did center stops, we did right stops for the equations, we did Alt N-E-I for inserting the equations. You don't have to know the shortcuts, but they really help when you're writing a big document. You don't need to, I won't know if you use them or not because they're on your end, right? But I want to teach you some of the easy pro tips that save you time. What question did you have on the PowerPoint?
I saw that it's due tomorrow night.
Mm-hmm.
I guess kind of what are we putting in the PowerPoint
Yeah.
and what's due?
Okay, yes. All right, so let's talk about that. Let me go to Blackboard to show you. So I put this up on Friday as I was driving in the car. Jennifer was driving and I was working. So let's see.
You're driving one of the self-driving cars, right?
No. She's driving and I'm on the passenger side with the laptop, cruising along. So this is week 4. So there's a new thing here. It says PowerPoint slides upload links. You click on that. It tells you upload your PowerPoint slides 2 only. So we're just gonna have two PowerPoint slides for our in-class discussion. Okay. So what I would like is if we look at the project, and I also added this checklist. So the project document is pretty long, when you're reading through, and you don't want to miss anything that you're supposed to have, right? So in order to help you make sure you've completed everything, I made a checklist.
I saw that. I was like, I don't think that was there before.
No, it wasn't. So this is new. I just went through all the numbered things that you needed to do, and I just made a little checkbox by all of them. So you can go through this. You can print this out. You can check your own little project and say, okay, I've checked off every box. And when you've checked every box, you've done the whole thing. There's a lot of boxes. Okay. And so then down here, this personal reflection, list and describe the things you learned about Excel, list and describe the things you learned about quantum mechanics, list and describe the things you learned about spectroscopy. Okay. And on your written report, you should have a cover page and everything, but this PowerPoint slide should include, I would say, something from this exploration section. And I think it should probably be like this idea, because we want everybody's to be different. We want, and so I think you should maybe think about this project and say, what did you learn about quantum mechanics or spectroscopy or Excel in this project? And you're probably going to really learn that in this exploration section. And so a slide could be about a problem that you had that you overcame, okay? Or it could be some interesting spectroscopic piece. So like the second slide might be something interesting. So maybe a slide, I'm making this up on the fly because what do we want to talk about, right? Something you overcame would be a good idea, okay? Yeah, that would be one slide. The other slide would be on something you learned, using an example from your project. And this is on the video, so you can go back and look at today's video, and we'll just block that in. Okay. Last thing I want is for us to have, let's see how many people, like 9 identical presentations of just, here's the spectrum I got, and everybody's looks the same because everybody followed the same cookbook. You know, that's boring for me and boring for you guys. Okay, I want it to drive you to think about what you're doing, and so that's what the PowerPoint's going to be about. Like, I had a problem with this Excel file, and I had a hard time, getting the like the parenthesis, or whoever had the parenthesis on the wrong side of the square or whatever. Yeah, it's like, hey, this is what I'm getting. I'm getting negative intensities. Don't just say I had a wrong parenthesis, but what did it produce? Like, go back and redo the error and see that all your intensities were negative, right? Because they weren't squared. And so that was a clue that there was something wrong with the transition dipole moment integral. Yeah, that's how I found it. So I was looking at that and I was like, okay, why am I getting negative intensities since they all should be positive? Yeah, and so that would be a good example. It's going to be, maybe five minutes of discussion. So you present your 2 slides and we can ask you questions and then go on to the next person. And then if we get finished early on Friday and we're done with all the presentations, then we can just study for the exam and you can ask me questions for the exam. So how's that sound? Now you're going to all speak really fast, but yeah.
So I guess to paraphrase, you want one slide where we look really stupid and one slide where we look really smart.
There you go. That's to put it in crude terms. But no, not the looking stupid, but just the overcoming problems. Yes. Yeah. No, that's with all of those formulas. There's nothing stupid about having a parenthesis in the wrong spot. That is, I don't know how many hours I've wasted doing the same thing or trying to chase down an error in a spreadsheet. Yeah. Yeah. So is everybody clear on that? Because again, we want clarity. We don't want you guys to be saying, "Man, I just don't know what I'm supposed to do, and I'm afraid to ask." Yeah.
I just have 2 really quick questions for the assignment itself. And these have been said by you before. I'm just
Go ahead.
confirming them for my own edification. We are copy pasting the questions into our assignment and then we're answering them
Yes.
in ACS format. So
Yeah.
our answers should be ACS format, but we're not going to have like a proper body paper.
Correct. You're not going to have. It's not going to look like a research report.
Okay, my introduction isn't going to be like an introduction. It's going to be just
It's going to be just the theory section on the. I think I have it on the Schrodinger equation or something like that. Yeah, the theory section here. Can you all see that? Yeah. So it's just a short introduction of the particle in the one-dimensional box wave function, identifying the fully identifying the variables. That part is really the ACS format I want. It's like, this is how you introduce an equation. Here's the equation. Here's how you identify the variables. Just like you've seen in other papers. Introduce the Schrodinger equation, identifying all parts. Break out the Hamiltonian operator, like where you see the second derivative operator and all of that. So, introduce the particle in the one-dimensional box energy equation, fully identifying all the variables. So this is all just one page. So that's great. That's the only one I'm really curious about ACS format, because I just want to see that drive you to the ACS style guide so that you get used to using it. Because you'll have questions when you're writing your thesis. How do I cite a web page? It's in there. How do I introduce a figure? It's in there. So those kinds of things I want you to get used to going to the style guide and answering those questions, rather than just waiting on your reviewers, your faculty reviewers, to pick out all of these problems, right? It's a waste of their time when you could have answered that question using the style guide. So it needs to be as perfect as possible before you turn it in as a draft, because you won't want them saying, "Oh, you need to capitalize, your figure captions, or you need to do this." Stylistic changes are a waste of everybody's time when you could have gotten that right from the beginning. Yeah. You want your advisor and your committee members to be focused on the science. And if it's full of grammatical mistakes and things like that and stylistic mistakes, they're not critiquing your science. And you're using their time as copy editors. copy editors are, you know, in terms of the job, you know, you have the editor, which sounds like he's a copy editor, but no, he or she is like the editor of the journal, looking at the science that's going out into the journal. They hire copy editors. Like, copy editors are the low people on the totem pole that are just checking for capitalization and grammatical errors and things like that. Don't turn your advisor and your committee into your copy editors. That's what your friends are for. And so y'all should pair up as you move through your program and say, hey, would you proof my thesis real quick? And you're not trying to like edit the science. Just make sure that there's no typos. Make sure that there are no incomplete sentences. I just need a fresh pair of eyes on this thesis so that I don't get embarrassed when I hand this off to my committee. Does that make sense? Yeah, and it'll really raise the bar for your work. And you'll build good friendships, because then you'll edit your friends' work and make suggestions, and then y'all go through that with each other a couple of times, and then you get used to that friendly peer review. That's what that is. It's like, quickly just run through this, you know, over the weekend if you would, and read my thesis and let me know where I've messed up grammatically and so on. Because then you won't be handing off something to your committee that you know, get back and it's just all red. Right? Yeah.
So once more confirming, the theory section, 100% answer your questions
Yeah.
in ACS format, no more than one page.
Yeah, and answering the questions in ACS, I mean, it's really not so much ACS format, except that just complete sentences in good grammar and spelling. Yeah, I'm not, yeah. So now you may want to use some figures. It talks about, does it talk about putting figures in here?
Yeah, is it ACS spell for figures and
Oh, yeah.
equations for the whole thing, or just the theory section?
The equation, you know, I'm just going to look at the theory section just to see if it looks right. Yeah, and then the discussion, I'm really focused on the science. Yeah, and so I'm not going to be like nitpicking the discussion section. I just want to see that you're answering with specific language instead of just saying, "Oh, it went up." I want to hear what went up. What is it, and what does up mean? You know, and so give, you know. When I say detailed responses, that doesn't necessarily mean long. It means you're using the vocabulary of the course, right? You don't just say, oh, the spectral intensities went up. But, you know, the transition dipole moment integral caused the transitions to go higher or whatever. So those kinds of things, using the vocabulary of the course. Okay. So I do have, let's see. I do have in the exploration section that everybody does the Raman piece. So this is the x squared psi piece, and then the, this is misspelled actually, but it should be psi x squared psi, not PDI. If you're looking at that going, what is PDI? It should be psi. And then what are the scattering selection rules? I mean, I pretty much did that in the last video where you saw the, you know, I did the Raman sheet. So you do have a way to check your work on that. But I'd like for you to do it. There's some skills that you need to know to do that. This one was pretty easy. I just went in and instead of x times psi, it was x squared times psi. That's pretty easy, right? And then paste it over and paste it down, and now I've got an x squared times psi page. And be sure to change the tab, you know, so that you see that it's x squared. This would all be in, cancel. This would all be in a new workbook. So copy that workbook and change the name to Raman instead of Absorbance or whatever it is that you have. And then you don't screw up the first one that you have. You know, so if you got the workbook, we did part 1, we saved it, and then we made a new one for part 2 just to have a save point. So then part 2 goes all the way through the spectrum. Now we take that one that's complete, starts with the wave function, goes all the way through the spectrum. We copy that again, make a third notebook, and we call that one Raman. and then we make the x squared and the x squared scattering moment integral here. So then we get those results. But in terms of the plotting, I went through and I want to show you this one thing. So if I were to select these little peaks down here, you see that the x-axis for all of the stick spectra is the energy, whereas on your absorbance one, it was wavelength. And so this is how when you copy it and change the name to Raman, your simulated spectrum, if you click on the stick spectra, you're going to see the name here. The red is the name of that series. The blue is the intensities. And then the X values are the wavelengths, the transition wavelengths. Well, for Raman, we don't plot that versus wavelength. We plot it versus Raman shift. And so we need to be plotted on the energy axis. So we just grab this purple bar here and drag it up to energy. And now those stick spectra are plotted versus energy. So that's all you have to do to move all of those stick spectra to the energy, being plotted by energy, not being plotted by wavelength. And then you come into the Gaussian peaks, the same thing. In your absorption values, it would be the transition wavelength is the peak center. You want to click on that first cell and you want to drag that purple one up. So the energy is the center of that Gaussian. And hit enter and then copy it over and copy it down. And that's how you create the energy spectrum. Yes?
Is there a specific question that mentions making the energy spectrum?
No. But the Raman I want to be plotted by energy. So I'm wanting everybody to take note of that. Because if you're trying to plot the Raman by wavelength and you want to include the Rayleigh line, that's at zero energy, so that's at infinite wavelength. So that's not going to be very nice to plot, right? Because you're dividing by zero if you've got zero energy difference. You can see up here, divide by zero, right? How are you going to plot that peak? By wavelength. Right here, you see that? Divide by zero. So that's the Rayleigh line. And so how do we get the intensity of the Rayleigh line? This is the intensity. This diagonal here is all the intensities of the Rayleigh line. And notice that Rayleigh intensity scattering is always at the energy change of zero because it was from state 1 to state 1 or state 2 to state 2. It's just no energy change. It's elastic scattering. So we need all of those intensities. So this is the third new thing, and I'm putting this in the video so that you guys know. So the intensity for that stick spectrum, notice over here it's the transition dipole moment integral times the Boltzmann distribution. That's the intensity of the stick. But for the Rayleigh line, it's different. So I wanted to sum up all of those intensities. So how do I sum up? Why is it? Oh, it's this one. Yeah. I wanted to sum up all of those guys. So I'm going to retype this formula in so you can see it. I want the Rayleigh intensities. I want all of them. Okay. So I'm going to say equals sum, open parenthesis. Okay. Then I'm going to go to my scattering dipole moment integral or scattering moment integral. It's not a dipole, it's a polarizability operator. So it's a scattering moment interval. And I go over there and I click the first diagonal. I hit a comma because I'm summing all of those. Second one, comma, third, comma, fourth, comma. Very easy. 6th, 7th, 8th, 9th, 10th. There's probably better ways to do this. You could do pluses. Okay. Close parenthesis, done. Okay, and so I've summed up all of those. Okay. And then, so that's there. Okay, and so then you see the spectrum. Now that Rayleigh line is way huge compared to all of those. So that's a more accurate picture. The one I showed in the last video 2 days ago, I had just taken the one of the intensity. I just multiplied by 10, but that wasn't nearly enough. It was really like 383 versus all of those other intensities. But this is what we see in a Raman experiment. The laser line is so bright compared to the Raman line. And so we would actually have to go in and change this for plotting. Let's make it, I don't know, what's the maximum here? Looks like 7. So let's go from 0 to 10. Yeah. And you see that the Rayleigh line just goes off scale. And that is what you see typically in a Raman experiment, that the Rayleigh line is just 100 times stronger than everything else. Or in this case, it's like 30 times, 38 times. So that's our Raman spectrum. Now what I would do if I were turning this in is I would make sure I go in here and I edit all of this stuff. This is the simulated Raman spectrum, so you got to edit the titles, and my laptop is really struggling. Okay. And it's R-A-M-A-N, it's not the noodles, it's Raman. Okay. And I have absorbance on this first one, but it shouldn't be absorbance. Oh, here it is, yeah. Let's say scattering intensity. Okay, so there we go. So that's our Raman spectrum, plotted by energy. And it's all on the video. You guys can see the 3 or 4 changes I made to the spreadsheet. So it's not like you have to redo the whole thing from the beginning. You just have to acknowledge that light absorption and emission is just 1x, because light is being modeled by x, the x-axis. So, and then scattering is a 2-photon process, so we use 2 x's. We have 2 electric fields, so we end up with x squared. And so we're going to use x squared to modify the initial wave function versus just plain x. So we changed to x squared psi, then we changed the selection rules. This sheet here, we actually didn't have to change it, because once we changed this sheet, then that one updated, and we got the selection rules for the Raman and the Rayleigh scattering. And then we come along and we can look at the Gaussian. Now, I also have the Lorentzian on here. I haven't changed those. Well, I guess I did change them. I didn't think I changed them. But you don't have to do that. I just did that for my spreadsheet. The log normal is one of your options. Let's see yeah. So here's some options that you can have. The application to real molecules or clusters. People have talked about the carotene molecules, like beta carotene with this really long conjugated chain, as being a particle in a box model. And so you could take the various leucine and carotene molecules and sort of estimate how long that conjugated chain is, and use that as your box length. So what would be the spectrum of an electron in that box? Instead of 7 angstroms, now you have one at who knows how many angstroms it is, maybe 30 angstroms. And you could measure what a particle in a box would be if it was on that conjugated chain. That's what I mean by application to real molecules. Option 2 would be going through and learning that error trap method to use the log normal line shape. So there you've got the same spreadsheet, but you're just adding the log normal line shape instead of the Gaussian. And then that would allow you to provide some examples of left and right tailing peaks, etc. You could try the particle on a ring. Again, this would be a whole new workbook. You would have to change quite a bit. This would be probably the most difficult one, okay? Because you would change your x from minus L over 2 to L over 2. You would have to make it minus 180 to 180, and you would have to figure out how to get that into theta, and you change the wave function. Pretty much you're changing everything. It still has the same structure, but you're changing everything on all the pages. Okay. I'm not discouraging you, but that's the toughest one, I think. And then the personal reflection, again, is pretty just descriptive there. Yes.
So, with that, Raman, activity under the exploration that you were just talking about, for the exploration, you said to start a new workbook.
Mm-hmm.
Would that mean we would upload another document, another
Yes.
Excel? Okay,
Yes.
that's my first question.
So on the Excel upload link for your project, you would upload both of them, yeah.
Okay, and then, so that ties to my other question when it comes to the exploration part.
Yeah.
You said new workbook, but did you mean create a new sheet?
Where?
When you add in when you put in the X squared?
Yeah, let's see.
I thought you said create a new workbook for that, but I wasn't positive.
I think you should create a new workbook for the Raman. Yeah.
Okay,
That way you have, you don't mess up the absorption one.
okay, so that would be a new workbook, and everything would be the same except for those two tabs where there's
Yeah.
an X squared.
X squared, yeah. And then you'd have to change your simulation so that it's plotted by energy, not by wavelength. Especially, yeah.
We'll be uploading 3 workbooks then.
No. Well, if you do a third one for, say, one of the, like if you did a log normal, yeah. But you should have one for parts 1 and 2. You don't have to include the very first one. That's just part 1 only. You're just making that as a save point. What I mean by that is if you get into the second part and you screw something up and you're like, I just want to scrap it and start over, you don't have to start from the very beginning. You can start at the end of part 1. But you don't have to turn that part in. That's just a preliminary, like, so you're working through, you get through part 1 and you've done the Schrodinger equation and all of that. You haven't simulated the spectrum yet. I would save everything, close everything, find my spreadsheet, hit copy and paste. And now I've got a copy of that workbook, and I would change the name to, complete or something, whatever. That lets me know this is going to be the whole thing. And then open that one and start editing that one going forward to finish part 2. It's just a smarter way to operate. When you're doing something that's huge and can be divided into chunks, and you're finished with the first chunk and you're about to start something really advanced on that piece, let's make a copy of that and start working on the copy so that I can always go back to where I was, just in case I screw that up. But you don't need to turn in that initial partial copy. So you'll turn in the complete workbook that has parts 1 and 2 in it, and you'll turn in the Raman workbook. And then if you make a third workbook with, say, log normal or whatever, that's fine. You could turn in a third workbook that says log normal line shape. And yes, well, he was first actually.
If I already did everything on the same workbook, am I good to turn in just one?
Yeah, but you're taking a risk. I'd advise against it because you can see my workbook's already starting to struggle, and it's probably because I'm running this video capture too. That's the RAM. It's filling up the RAM on my computer. But I just have seen people distraught over their one single workbook being corrupted and them not being able to do it. And it happens the day it's due, always. Always, yeah. And, I can't tell you how many backup copies of every paper and thesis that I had that I was able to archive and then just delete once I turned in the final one, I would always at least keep like 2 backups, okay, while I was working. And then I make a new one, and then I would delete the oldest backup. But that way, now, of course, OneDrive says it has version histories and stuff like that, and that's great in a pinch. But you really need to work smart on bigger projects, and especially on your thesis, of having 2 or 3 backups. My file name convention is always this. So if I'm going to be writing, so if I were to write a document today, it would be this, 2025-09-15 thesis draft. Okay? That tells me that was today's version. And so I'm going along, and .docx, right? Okay, and so then I'm going along and I get back to it in 5 days because it's been a busy week and DW's project is wearing me out. And so I get back to it on, say, the 21st, okay? So then I copy this in my file manager or whatever. I copy that file, I come down here and I paste it, and it says, thesis draft dash copy, right? You see this in the thing. So then I come in here and I change the date to 21, and I come over here and I delete this. and then I start working on that one. So I have the old one, but what I'm starting today is on a new copy, and I keep 2 back copies so that if something goes wrong, I have at least a couple of options to go back to, so that I don't lose a chunk of work. Yeah, you gotta I don't trust these damn computers. I mean, they will. Right when you need it most, it's like stab you in the back, and you're like, Bill Gates, I hate you. So you just gotta really be smart, you know, and don't let yourself be vulnerable. Yeah. Yeah. Did I get your question?
It was the same as his.
Okay. Yeah. So we're spending a lot of time in class talking about this because this is actually where you guys are going to learn. You're going to learn more fiddling around with this and saying, okay, now I feel like I understand how the wave function is modified by light and what that does for the selection rules, and then I get a spectrum and I have the line shape, and you play around with the resolution and those things, and so you'll just be better at spectroscopy after doing this project. It's way better than I could ever get you to learn by preparing for a test. Okay, so that's why we're spending so much time on it, and I think it'll pay off. Then later on, we're going to have a big project at the end where we are modeling things in Gaussian, and we're then going through a spreadsheet that gives us the color of that object, and that's so satisfying. That's sort of our pinnacle project at the end, and you guys will understand then how the molecular spectrum interacts with our eyeballs, and how we get this perception of color. And it's just a really fun ending to the course. So there's a lot of Excel, of course, but it really enables you to do a lot of great analysis. So I think that it's valuable. We've got 10 more minutes. What do y'all want to do? Don't say sleep. Yes. Yes, let me look at the links, make sure that makes sense. Okay, so we have the PowerPoint slide up link. So that's due tomorrow night, just because I need to have something for class. Like Wednesday morning, I'll take all of the ones that y'all have put in, and I'll put them in one PowerPoint up here on my laptop, and then you can all present from the same file. Okay. It's not one of those things that, yes, it's due Tuesday night, but if you need a little bit more time, like you're really onto something, you want it to really be good, it's okay if you're a little bit late, because we also have Friday to present. But like, let's go ahead and try to hit Tuesday night. If you can't, then we'll do Friday. You know, you'll present Wednesday if you get there. But if we don't, like, if you really are onto something good, don't turn in junk. You know what I'm saying? Like, go ahead and finish it out, and then you'll present on Friday. Okay. But we need a few people. We need at least 5 people to hit the Tuesday night deadline. Okay. So y'all can draw straws, get a deck of cards out there. You know.
First bench.
Huh?
First bench.
First bench. Yeah. How about right side? Yeah. So I know that's a little too flexible for students that are like, oh, well, I'm going to wait till Friday morning. But no, y'all are mature. If you can get something cool done by Tuesday night, do it, and let's have you go first. You know, that'll be great. Yeah. Okay. And then let's see. And so then that's the PowerPoint slide. Then here's the numerical methods report submission link. So this is a Turnitin. You see the little doorway or paper, I guess. And so when you go to that link, it starts this thing called a LTI, and you can submit it. Now this is not yet. This is my view, so it's not relevant to you guys. You'll have an upload and you'll have some things, but it's important when you upload your paper, your document, Word document, to Turnitin, that you, I think it's a PDF. Don't I have you print a PDF? Is that in the checklist? Anyway, whatever you upload to Turnitin, it takes a while for the submission to go through. So don't leave the window until you see submission complete. Okay, that's important. Yeah. And after you're done, if you want to make sure that it's there, you can kind of go to see what you submitted. And if you don't see anything there, then something went wrong. So, you know, you can try it again.
You should get an email as well that
Oh,
you
yeah?
turn it in.
Okay.
I had that happening.
Okay.
I did I submitted a report
Yeah.
to turn it in,
Yeah.
and I never got that email. And over a month later, I was looking at my grades in my grade book, and I had a 0 for that
Yeah.
report that I had turned in
Yeah.
and everything.
That's
and I
why that's
contacted
why I'm making a point of this, because so
Yeah.
many students have been, yeah. So then here's the Excel submission link, and that's where you put all your Excel files. So if you have 3 files, just upload all of them, and I'll see them all come through. Just make sure that the file names make sense. You know, if it's Raman, put Raman in there. If it's Absorbance, put Absorbance. If it's log normal, put that in there. If it's beta carotene and other whatever, you know, but whatever it is that you guys got, yeah. And so that's it. Just three links. A Word document or a PDF, either way. The Excel files, multiple ones, and then the PowerPoint slides. How far are you along on this? Have y'all finished the absorbance one? Like parts 1 and 2 on the first? That's good. Okay. Have you played with it? Changed the line shape and changed the width of the peaks and all that stuff? Okay. Who's done the Raman already? Anybody?
I've done the Raman, but neither has plotted it yet.
Okay.
We put it on the same spreadsheet.
Same thing with the log normal.
Yeah, I put everything on.
Yeah, and that's okay.
Can I keep it since I already have
Yeah,
it?
you can keep it. Yeah, absolutely.
So I
Yeah.
really don't hurt.
No, I agree with you. Yeah, it's yeah. No, I agree with you. Yeah, I'm not going to make you do that just because. But you got a backup, don't you?
Yeah.
Okay, good.
And everything's labeled properly.
That's good. Yeah, that's also important too, that the spreadsheet be super clear. Like you see what I did with mine. I tried to make it super clear. So take that on as a best practice. Like you are communicating in principle. You're communicating to your future self. Because you're going to pull this thing. You're probably the most likely one to pull up this spreadsheet years later and wonder what it is. And so you need to tell yourself, what is this? And what is this page? And so on. And how did I do it? Okay. Yes.
And is it fine to have all 3 on the control page if they're each labeled? So I can control it and then see all 3 of them?
Yeah, that's cool. Like you have the Raman here and the infrared, the absorbance and then the log normal. Yeah, that's cool. That'd be great. Yeah, absolutely. You're a lot of flexibility. Yeah. So, yeah, that's really good. I may do some screenshots of that. It looks really nice. Like show it if you want to make that part of your PowerPoint. It's like, oh, I wanted to see everything on one sheet, and so that's something that was good.
And then if I'm taking those pictures from the thing and I'm putting it in my report, is it fine if the background is still gray and it's not?
Yeah, it's okay. So like if I wanted to get this, so here, let's do this. We've got a little bit of time left. Let me do Word again. Okay, here is a cool figure. And I want to insert that. So I click on it. I do Control C. You could right click and copy, that's fine. Come over here to Word. Now, if you just hit paste, okay, this is linked to that Excel file, and you don't want to do that. If you delete that Excel file or change the name or something like that, then this shows up as a missing reference. And that's terrible for your thesis if something happens, and all of a sudden your figures are no longer in your thesis. So you don't ever want to link the files together. Bill is trying to help us out, but it's not a good idea. Okay, so go to Paste Special, and then you have all these options. Now, I have had very good luck with Enhanced Metafile, this picture Enhanced Metafile, okay? PNGs work well too, but I just have always used the Enhanced Metafile. But
So I don't know if it's just because I'm on a Mac, but I don't have that option. Can I just use the PNG?
yeah, you can use the PNG, yeah. So you hit OK, and there's your figure, okay? It's beautiful. Okay, so we go along, and then we want to do this. Right-click the figure, and see here it says Insert Caption. Then it says Figure 1, and we'll say the scattering spectrum of a particle in a box. 1D PB. Okay. There. So there's our figure caption, and then up here, if I wanted to put a reference to that, I could come up here and say, on the References tab, I could do cross-reference, and it's Insert Reference Type, Figure, okay? I could insert the entire caption, but I just want the label and the number, and I hit OK. Close. Now, this is a dynamic. See how it's gray when I click on it? I click everywhere else, there's no gray, but I get to this and I see that gray box. That means that's like a hyperlink type thing, but it's not external, it's inside the document. So then if I created another figure in front of this one, this would become figure 2, and my text would update. And it would be referring to the correct figure because now it's figure 2. So that's also what you want to do in your thesis, is you want to, at least for your figures, use this figure captioning. And then when you create your table of figures, it'll be done automatically. And so that's also very nice. And if you move your figures around, your table of figures also will adapt. And that helps you avoid these copy errors, you know. So that's very good. PNG will work. You can also use, let's say you wanted to get some of the Excel text too. You may have to resort then to the snipping tool. So Windows Shift S will launch the snipping tool. And you can come up here, there's different ways to snip. Sometimes you want to do rectangle, and then you can come down here and you can pick the figure and some of the Excel file behind it, because that may be what you want, I don't know. But see, now you see you've got the tables from Excel up above it, and you've got the figure, and that's done with the snipping tool. And that's a PNG typically inserted. Yes?
So if I wanted to take like the table that has all my selection rules,
Yeah.
does that have to be ACS format too, or can I just literally have the grid lines?
No, it's just that first section that I'm checking for ACS, yeah. The discussion questions, I'm just focusing on communication. Can you tell me what you did and what you learned? Yeah. All right, we're out of time.
You want us to fill out the attendance?
Yeah, might as well. Thank you.
Next week's for